In late 2019, the Macquarie River, one of the major waterways feeding into Australia's Murray-Darling Basin in western New South Wales, had shrunk to a chain of shallow, disconnected pools. A multi-year drought, among the most severe on record, had reduced river flows to a trickle, and fisheries officers moving along the riverbed found native fish stranded in pools that were rapidly drying up, running out of oxygen and heating to temperatures the fish could not survive. It was, in the words of the officers documenting it, a river on the edge of losing its most iconic species entirely. Not far away, on the Darling River at Menindee, the same drought had already produced a catastrophe that made international headlines. Across a series of mass fish deaths in December 2018 and January 2019, an independent expert panel concluded that over 1 million native fish had died along a single 40-kilometer stretch of river, mostly bony herring, but also including Murray cod, golden perch, and silver perch, species central to the entire river system's food web and to the region's cultural and recreational identity. The panel's investigation found the immediate cause was a collapse in dissolved oxygen, triggered when a severe drought allowed a large blue-green algae bloom to form, die off, and consume the water's remaining oxygen as it decomposed, with a sudden cold snap, then mixing the oxygen-starved bottom layer through the entire water column. But the panel was equally clear that the underlying cause ran deeper than any single weather event. There was simply not enough water left in the system after decades of upstream irrigation diversion to protect the fish through a drought this severe. The mechanics behind why a drought produces a fish kill of this scale are worth understanding because they explain why the crisis felt as sudden as it did to communities living along the river. Under normal conditions, a flowing river mixes oxygen through its water column continuously, keeping dissolved oxygen levels high enough to support fish throughout the water depth. During a severe drought, when river flows drop to a fraction of their normal volume, water can become effectively stagnant, allowing it to separate into distinct layers, a warmer, oxygenated layer near the surface sitting on top of a cooler, oxygen-depleted layer below. Blue-green algae blooms, which thrive in these same stagnant, nutrient-rich, slow-moving conditions, can then die off in large quantities, and as they decompose, the bacteria breaking them down consume whatever oxygen remains in the water. When a sudden weather change, such as a cold front, finally mixes these separated layers back together, the oxygen-poor bottom water spreads throughout the entire water column, and fish that had been surviving in the thin oxygenated surface layer are suddenly left with nowhere left to breathe. It is a mechanism that can kill an enormous number of fish within a matter of hours once triggered, which is part of why the Menindee events proved so shocking even to experienced river ecologists. Against that backdrop, in November of 2019, fisheries staff working the Macquarie River made a decision that would turn into one of the most successful native fish recovery programs in the basin's history. Rather than simply documenting another mass die-off, they moved to physically rescue the surviving breeding-age fish before the drought could take them too. Over that rescue operation, officers recovered more than 250 adult Murray cod and golden perch from the drying river. Most were relocated to safer stretches of water or transferred to other hatcheries to support their own broodstock programs. But 60 of the rescued fish, 25 Murray cod and 35 golden perch, were taken specifically to the New South Wales government's Narrandera Fisheries Centre, a dedicated native fish hatchery built to breed and rear exactly this kind of emergency broodstock population. What happened at that hatchery over the following 5 years defied even the expectations of the fisheries staff who had planned the rescue. Working from just 60 adult fish, the breeding program at Narrandera produced more than 1 million fingerlings, an enormous multiplication of a population that had, just months earlier, been counted among the casualties of one of the worst river droughts in Australian history. Producing fingerlings at that scale is itself a delicate technical undertaking. Adult broodstock have to be brought into breeding condition under carefully controlled water temperature and photoperiod, a process that mimics the natural seasonal cues fish rely on in the wild. Fertilized eggs then have to be incubated at precise temperatures, and once hatched, the resulting larvae are exceptionally fragile, requiring exact concentrations of live plankton for food, protection from disease, and painstaking monitoring at every stage before they are large enough, as fingerlings, to survive being released into open water. Multiplying 60 rescued adults into more than 1 million young fish across 5 years represents years of continuous, carefully managed hatchery work, not a single dramatic release event. Murray cod deserve a moment of their own explanation since they sit at the center of this entire story. They are Australia's largest exclusively freshwater fish, capable of growing beyond 1.5 meters in length and living for decades in a single stretch of river, often occupying the same submerged log or hollow for years at a time. Long before European settlement, Murray cod were a critical food and cultural resource for First Nations communities across the basin, and the species remains deeply significant to groups including the Barkindji people of the Darling River region today. Losing Murray cod at the scale the 2018 to 2019 fish kills threatened was never simply an ecological statistic. It represented the potential loss of a species that had anchored the region's river ecosystems, economies, and indigenous cultural practices for thousands of years. As conditions in the wild improved and drought gave way to more favorable river flows, those fingerlings began going back into the water. More than 250,000 Murray cod fingerlings bred from the rescued Macquarie River broodstock have since been released at multiple sites along the river, including at Wellington, Dubbo, Narromine, Trangie, and Warren, directly rebuilding the same population the drought had nearly wiped out just a few years earlier. The final chapter of the story came 5 years after the original rescue. In 2024, 19 of the original adult Murray cod that had been pulled from the drying Macquarie River back in 2019 were finally returned to their home waters, having spent 5 years at the Narrandera hatchery as the broodstock foundation for the entire recovery effort. Having done the work of producing more than 1 million descendants between them, these original survivors were released back into the river system they had originally been rescued from, closing the loop on a program that began as an emergency drought response and ended with both a massively expanded fish population and the literal return of the fish that made it possible. This kind of rescue and breed response was not limited to the Macquarie River alone. Following the Menindee mass fish kills specifically, NSW Department of Primary Industries Fisheries, working with the Murray-Darling Basin Authority, launched a parallel effort called Recovering the Lower Darling, aimed at protecting the Darling River's own remnant native fish populations through similar rescue, breeding, and restocking work. Broodstock rescued from the Lower Darling produced their own substantial numbers of fingerlings over the following seasons, with tens of thousands released back into the Barka, the traditional name for the Darling River used by the Barkindji people, whose communities took part directly in several of the fish release events alongside fisheries staff. Community-based native fish stocking across New South Wales extends well beyond the emergency Macquarie and Darling River rescues. Through a long-running program that matches community and council funding on a $2 to $1 basis, dozens of local fishing clubs, shire councils, and agricultural associations across the state have collectively released more than 15 million native fish into New South Wales waterways since the program began in the late 1990s. Individual council partnerships, such as the decades-long stocking effort between Narromine Shire Council and local cotton growers along the Macquarie River, have added hundreds of thousands more fingerlings over the years, an ongoing, less dramatic complement to the emergency drought response breeding work carried out at Narrandera. It would be misleading to present this story as a simple, unqualified triumph, and the scientists closest to the recovery effort have been careful not to describe it that way. Restocking programs across the Murray-Darling Basin face a genuine and persistent set of challenges that breeding more fish by itself cannot fully solve. A 2024 study tracking stocked Murray cod using genetic parentage analysis found that a significant share of released fingerlings were being drawn directly into unscreened irrigation pump intakes, in some cases within 24 hours of release, removing them from the river population almost as quickly as they had been added to it. Researchers studying the broader restocking effort across the basin have pointed out that native fish populations remain estimated at roughly 10% of their levels before European settlement, and that restocking alone, without also addressing the underlying pressures of water extraction, barriers like dams and weirs blocking fish migration, cold water pollution released from the base of large dams, and invasive species such as carp, is unlikely to reverse that long-term decline on its own. The struggle has also proven far from over. In March of 2023, following 3 years of unusually heavy rain and flooding that had brought the basin's rivers back to life after the earlier drought, Menindee experienced another mass fish kill, this time linked to blackwater, oxygen-depleted runoff, carrying decomposing organic matter from the floodplains back into the river as floodwaters receded. Some estimates place the death toll from this second event in the tens of millions, an outcome that stunned researchers precisely because it followed years of abundant water rather than drought, demonstrating that the underlying vulnerability in the system runs deeper than rainfall alone. Independent scientists who investigated both the 2019 and 2023 events have pointed to a consistent underlying pattern. Heavy upstream water extraction for irrigation leaves the river system with too little buffering capacity to absorb either extreme, whether that extreme arrives as drought or as flood. What the Macquarie River recovery genuinely demonstrates, then, is not that restocking alone can undo everything that has gone wrong in the basin's rivers, but that a fast, well-resourced emergency response, built around rescuing the right breeding age fish at exactly the right moment, can prevent a specific acute crisis from becoming a permanent, irreversible loss. 60 fish, rescued from pools that were days from drying up entirely, produced more than 1 million descendants and, 5 years later, went home themselves. Whether that recovered population can be sustained long-term will depend on the slower, less dramatic work of fixing irrigation infrastructure, restoring river flows, and managing water extraction across the basin. Work that is still very much underway, without the kind of single decisive moment a rescue story naturally provides. Invasive species add a further complication that pure restocking numbers can obscure. Carp, introduced to Australia in the 19th century and now dominant by biomass in many stretches of the Murray-Darling system, degrade water quality by stirring up sediment as they feed, damage stream banks, and compete directly with native species for food and habitat. Fisheries researchers have noted that restocking native fish into a river still heavily dominated by carp addresses only one side of the underlying imbalance, which is part of why parallel carp control efforts, including a long-studied but not yet deployed biological control agent based on a carp-specific herpes virus, remain an active area of research alongside the native fish breeding programs themselves. A river can receive 1 million new native fingerlings and still face an uphill battle if the invasive species crowding them out are left unaddressed. The Narrandera Fisheries Center itself has quietly become one of the most important pieces of infrastructure in the entire basin's native fish recovery effort, precisely because of episodes like this one. Built as a dedicated native fish hatchery, it exists specifically so that when a crisis like the 2019 Macquarie River drought hits, there is already a facility on standby with the tanks, water systems, and trained staff needed to take in rescued broodstock immediately, rather than scrambling to arrange emergency housing for hundreds of stressed, drought-affected adult fish with nowhere else to go. That kind of standing capacity is easy to overlook in a story focused on dramatic rescue numbers, but it is arguably what made the entire recovery possible on the timeline it happened. Without a hatchery already equipped and staffed to receive 60 adult Murray cod and golden perch on short notice in November 2019, the rescued fish would have had far lower odds of surviving long enough to breed at all, let alone to produce 1 million descendants over the following 5 years. Minister for Agriculture and Regional NSW Tara Moriarty, speaking at the 2024 release of the original rescued adults back into the Macquarie River, described the returning fish as having made what she called a monumental contribution to rebuilding Murray cod and golden perch numbers across the state, language that captures something genuinely unusual about this particular recovery story. Most species rescues end with the rescued animals remaining in captivity indefinitely, or with their descendants eventually released while the original individuals live out their lives at the facility that saved them. Here, the original 60 fish not only survived and bred at a scale nobody had fully anticipated, they lived long enough and remained healthy enough to complete the full circle themselves, swimming back into the same river system they had been pulled from as it neared collapse 5 years earlier. If stories like this one about the real complicated work behind an emergency species rescue are the kind of thing you want more of, subscribe, and I will see you in the next one.